Using a fuse disconnect in a multi-phase circuit can present additional risks. If a single fuse opens while the other phases remain closed, this can result in a condition known as single phasing. Single phasing occurs when one phase of a multi-phase circuit is interrupted while the others remain energized. This causes the motor to operate with an unbalanced current, leading to overheating and potential damage. It can result in decreased torque, increased noise, and eventually motor failure. Single phasing can cause more damage than a three-phase fault because the motor operates at higher temperatures due to the unbalanced current. The increased heat can damage the motor windings, insulation, and bearings. The resulting electromagnetic forces can lead to vibrations and mechanical stress. A breaker trip protects all three phases simultaneously, preventing single phasing. A fuse disconnect, on the other hand, can interrupt only the phase it is protecting, increasing the risk of single phasing. To minimize the risk of single phasing and damage to the equipment, it is generally recommended to use a non-fused disconnect as the local means of disconnect in a multi-phase circuit. This ensures that all three phases are disconnected together, preventing the possibility of single phasing. In some cases, engineers may still choose to use fused disconnects for motor-driven devices depending on the specific circumstances. For example, fuses may provide faster fault clearing than breakers, which can be beneficial in protecting critical equipment. However, it is important to carefully consider the potential risks of single phasing and to implement additional protection measures as necessary to mitigate those risks. Fuses are current limiting devices that interrupt a circuit when an overcurrent condition occurs. They are designed to protect equipment and personnel from damage caused by short circuits or overloads. Circuit breakers are electromechanical devices designed to protect electrical circuits from overcurrent conditions. Unlike fuses, which are single-use devices, circuit breakers can be reset and reused after tripping. They offer the advantage of providing both overload and short-circuit protection, and they can be manually switched to disconnect a circuit. A non-fused disconnect switch is a type of electrical switch that provides a means to manually disconnect a circuit or piece of equipment from its power source. Unlike fused disconnects, non-fused disconnects do not contain fuses for overcurrent protection. Their primary purpose is to provide a safe and convenient way to isolate equipment for maintenance or repair. Overload protection is designed to protect motors and other electrical equipment from damage caused by excessive current draw over a period of time. Overload relays or electronic overload protection devices are typically used to monitor the motor current and trip the circuit if the current exceeds a predetermined level for a specific duration. This prevents overheating and potential damage to the motor windings. A three-phase fault occurs when a short circuit happens between all three phases of a three-phase electrical system. This type of fault results in very high fault currents and can cause significant damage to equipment if not quickly cleared. Protective devices such as circuit breakers and fuses are designed to detect and interrupt these fault currents to protect the system. The National Electrical Code, or NEC, provides guidelines for the safe installation of electrical wiring and equipment. It covers various aspects of electrical installations, including conductor sizing, overcurrent protection, grounding, and wiring methods. Adhering to the NEC helps ensure electrical systems are installed safely and function properly. A combination starter integrates a motor starter with a disconnect switch or circuit breaker in a single enclosure. It offers a convenient and compact solution for motor control and protection, providing both a means of disconnecting the motor from the power source and a motor starter for controlling the motor's operation. Motor starters are electromechanical devices used to start and stop electric motors. They typically consist of a contactor, which is an electrically controlled switch, and overload protection to protect the motor from damage due to overcurrent conditions. Motor starters can be manual or automatic, and they are available in various types and sizes to suit different motor applications. Torque is a rotational force that causes an object to rotate. In the context of electric motors, torque is the force that the motor exerts to turn its shaft and drive a load. The amount of torque a motor can produce depends on its design, size, and operating conditions. Insulating materials are used in electrical equipment to prevent the flow of current between conductors and to provide electrical isolation. Common insulating materials include polymers, ceramics, and fiberglass. Proper insulation is essential for preventing electrical shocks, short circuits, and equipment failures. Bearings are mechanical components used to reduce friction between moving parts. In electric motors, bearings support the rotor shaft and allow it to rotate smoothly. Bearings are typically made of steel or other durable materials and are lubricated to minimize friction and wear. Electromagnetic forces are forces produced by the interaction of electric currents and magnetic fields. In electric motors, electromagnetic forces are responsible for producing torque and causing the rotor to rotate. These forces are proportional to the current flowing through the motor windings and the strength of the magnetic field. Vibration in electrical equipment can be caused by a variety of factors, including unbalanced rotating parts, loose connections, and electromagnetic forces. Excessive vibration can lead to equipment damage, noise, and reduced performance. Vibration monitoring and analysis techniques can be used to detect and diagnose vibration problems in electrical equipment. Mechanical stress refers to the internal forces and stresses that develop within a material when it is subjected to external loads or forces. In electrical equipment, mechanical stress can be caused by factors such as vibration, thermal expansion, and electromagnetic forces. Excessive mechanical stress can lead to material failure and equipment damage. The interrupting rating of a fuse or circuit breaker is the maximum fault current that the device can safely interrupt without failing or causing damage to the electrical system. It is an important parameter to consider when selecting overcurrent protection devices to ensure that they can adequately protect the system from short circuits and other fault conditions. Grounding provides a low-resistance path for fault currents to flow back to the source, helping to protect equipment and personnel from electrical shock hazards. Grounding also helps to stabilize voltage levels and reduce electrical noise in the system. Proper grounding is essential for ensuring the safe and reliable operation of electrical systems. Single-phasing in three-phase motors results in several adverse effects due to the unbalanced electrical supply. Firstly, the motor experiences a significant reduction in torque, potentially causing it to stall under load. The remaining phases carry increased current, leading to overheating of the motor windings. This overheating can degrade the insulation, shortening the motor's lifespan and potentially causing premature failure. The motor may also exhibit increased noise and vibration due to the uneven magnetic field distribution. Furthermore, single-phasing can lead to inefficient operation and increase energy consumption. To mitigate these risks, it is essential to implement protective measures such as three-phase overload relays and voltage monitoring devices that can detect single-phasing conditions and quickly disconnect the motor from the power supply. In electrical systems, ground fault protection is crucial for preventing electrical shocks and minimizing damage from ground faults. Ground faults occur when current leaks from a live conductor to ground or a grounded object. Ground fault circuit interrupters, known as GFCIs, are designed to detect these faults and quickly interrupt the circuit, protecting personnel from electrical hazards. Ground fault protection systems, or GFPs, are used in industrial and commercial applications to protect equipment and prevent extensive damage from ground faults. Regular testing and maintenance of ground fault protection devices are essential to ensure their proper functioning and effectiveness. Harmonics are distortions of the normal sinusoidal waveform of alternating current, or AC, power. They are typically caused by nonlinear loads such as electronic devices, variable frequency drives, and uninterruptible power supplies. Harmonics can cause a variety of problems in electrical systems, including overheating of transformers and conductors, increased energy losses, and malfunction of sensitive electronic equipment. Harmonic filters and other mitigation techniques can be used to reduce harmonic distortion and improve the power quality of electrical systems. Surge protection devices, or SPDs, are designed to protect electrical equipment from transient voltage surges caused by lightning strikes, power grid switching, and other disturbances. SPD divert the surge current away from sensitive equipment, preventing damage and ensuring reliable operation. SPD are commonly installed at service entrances, distribution panels, and individual equipment locations to provide comprehensive surge protection. Regular inspection and testing of SPD are important to ensure their proper functioning and effectiveness. In electrical engineering, impedance refers to the opposition to the flow of alternating current, or AC, in a circuit. It is a combination of resistance and reactance, which includes both inductive and capacitive reactance. Impedance is measured in ohms and is frequency dependent. Understanding impedance is essential for analyzing AC circuits and designing impedance matching networks for efficient power transfer. Power factor is a measure of how effectively electrical power is being used in an AC circuit. It is defined as the ratio of real power, measured in kilowatts, to apparent power, measured in kilovoltamps. A low power factor indicates that a significant portion of the current is not being used to perform useful work, resulting in increased energy losses and reduced system capacity. Power factor correction techniques, such as using capacitors, can be implemented to improve the power factor and increase the efficiency of electrical systems. The skin effect is a phenomenon in AC circuits where the current tends to flow near the surface of a conductor rather than uniformly throughout its cross-sectional area. This effect is more pronounced at higher frequencies and with larger conductors. The skin effect increases the effective resistance of the conductor, leading to increased energy losses. To mitigate the skin effect, conductors can be designed with a larger surface area, such as using hollow conductors or bundling multiple smaller conductors together. Voltage drop is a decrease in voltage that occurs along a conductor due to its resistance. Voltage drop can cause equipment to operate inefficiently or malfunction, especially in long circuits or with heavy loads. To minimize voltage drop, conductors should be sized appropriately based on the load current, distance, and allowable voltage drop. Voltage drop calculations are essential for ensuring that electrical systems operate within acceptable voltage limits. Transient voltage refers to a short-duration surge or spike in voltage in an electrical system. Transients can be caused by lightning strikes, switching operations, and other disturbances. Transients can damage sensitive electronic equipment and cause system malfunctions. Surge protection devices, or SPDs, are used to protect equipment from transient voltage surges by diverting the surge current away from the equipment. A short circuit is an abnormal electrical condition where current flows through an unintended low resistance path, bypassing the normal circuit. Short circuits can be caused by insulation failures, loose connections, or accidental contact between conductors. Short circuits result in very high fault currents, which can cause equipment damage, fire, and electrical shock hazards. Overcurrent protection devices, such as fuses and circuit breakers, are designed to detect and interrupt short-circuit currents to protect the system. Arcing is a phenomenon where electrical current flows through the air between two conductors. Arcing can occur when there is a voltage difference between the conductors and the air becomes ionized, creating a conductive path. Arcing can cause equipment damage, fire, and electrical shock hazards. Arc flash protection devices and techniques are used to minimize the risk of arcing faults and protect personnel from arc flash hazards. Electrical resonance is a condition in AC circuits where the inductive reactance and capacitive reactance are equal, resulting in a maximum current flow at a specific frequency. Resonance can cause voltage and current amplification, which can damage equipment. Resonance can be used in tuned circuits for filtering and other applications. Understanding resonance is important for designing and analyzing AC circuits. Common mode noise is a type of electrical noise that appears equally on all conductors in a circuit relative to ground. Common mode noise can be caused by electromagnetic interference or EMI, radio frequency interference or RFI, and other sources. Common mode noise can interfere with the operation of sensitive electronic equipment. Common mode chokes and filters are used to reduce common mode noise in electrical systems. Differential mode noise is a type of electrical noise that appears as a voltage difference between two conductors in a circuit. Differential mode noise can be caused by switching operations, power supply noise, and other sources. Differential mode noise can interfere with the operation of sensitive electronic equipment. Differential mode filters and shielding techniques are used to reduce differential mode noise in electrical systems. Electromagnetic compatibility, or ENC, is the ability of electrical equipment to function properly in its intended electromagnetic environment without causing interference to other equipment. EMC standards and regulations are designed to ensure that electrical equipment meets certain performance requirements and does not cause unacceptable levels of interference. EMC testing and certification are used to verify that electrical equipment complies with EMC standards. Variable frequency drives, or VFDs, are electronic devices used to control the speed of AC motors. VFD adjusts the frequency and voltage of the power supplied to the motor, allowing for precise speed control and energy savings. VFD are commonly used in industrial and commercial applications to control pumps, fans, compressors, and other types of equipment. Power quality refers to the characteristics of the electrical power supply to equipment and systems. Poor power quality can cause equipment malfunctions, reduce performance, and increase energy losses. Power quality monitoring and analysis techniques are used to identify and diagnose power quality problems. Power quality improvement techniques such as harmonic filtering, surge protection, and voltage regulation can be used to improve the power quality of electrical systems. Cable tray systems are used to support and route electrical cables and wiring in industrial and commercial buildings. Cable trays provide a safe and organized way to manage cables, reducing the risk of damage and electrical hazards. Cable trays are available in various types and sizes to suit different applications. Conduit is a rigid or flexible tube used to protect electrical wiring from damage and environmental factors. Conduit is typically made of metal or plastic and is available in various sizes and types. Conduit is used in both indoor and outdoor applications to provide a safe and reliable wiring pathway. Junction boxes are enclosures used to protect electrical connections and splices. Junction boxes provide a safe and convenient way to make wiring connections and prevent electrical hazards. Junction boxes are available in various sizes and types to suit different applications. Terminal blocks are modular connectors used to terminate electrical wires and cables. Terminal blocks provide a secure and organized way to connect wires, making it easier to install and maintain electrical systems. Terminal blocks are available in various types and sizes to suit different applications. Grounding electrodes are conductive objects used to establish a connection to the earth for grounding purposes. Grounding electrodes can be rods, plates, or other conductive objects that are buried in the ground. Grounding electrodes provide a low resistance path for fault currents to flow back to the source, helping to protect equipment and personnel from electrical shock hazards. Bonding is the process of connecting metallic objects together to create a low impedance path for fault currents. Bonding helps to equalize voltage potentials and reduce the risk of electrical shock hazards. Bonding is required by electrical codes for various types of equipment and systems. Electrical schematics are diagrams that use symbols to represent the components and connections in an electrical circuit. Schematics are used to design, analyze, and troubleshoot electrical circuits. Understanding electrical schematics is essential for electrical engineers, technicians, and electricians. A multimeter is a versatile test instrument used to measure voltage, current, resistance, and other electrical parameters. Multimeters are essential tools for electrical troubleshooting and maintenance. Multimeters are available in both analog and digital versions. An ammeter is an instrument used to measure electric current. Ammeters are connected in series with the circuit to measure the current flowing through it. Ammeters are available in both analog and digital versions. A voltmeter is an instrument used to measure voltage. Voltmeters are connected in parallel with the circuit to measure the voltage across it. Voltmeters are available in both analog and digital versions. An ohmmeter is an instrument used to measure resistance. Ohmmeters are used to measure the resistance of components, circuits, and insulation. Ohmmeters are available in both analog and digital versions. A megometer, also known as a megger, is an instrument used to measure high resistance values, typically for insulation testing. Megameters apply a high voltage to the insulation and measure the leakage current to determine the insulation resistance. A clamp meter is a type of ammeter that measures current without requiring the circuit to be broken. Clamp meters use a clamp-on probe to measure the magnetic field around a conductor, which is proportional to the current flowing through it. A thermal imager is a device that detects and displays temperature variations on a surface. Thermal images are used to identify overheating components, insulation problems, and other thermal anomalies in electrical equipment and systems. A power analyzer is an instrument used to measure various power parameters, such as voltage, current, power factor, harmonics, and energy consumption. Power analyzers are used to analyze power quality and optimize energy efficiency in electrical systems. A cable fault locator is a device used to identify and locate faults in electrical cables. Cable fault locators use various techniques, such as time domain reflectometry, or TDR, to pinpoint the location of shorts, opens, and other cable faults. Electrical safety is the practice of protecting people and property from electrical hazards. Electrical safety practices include proper wiring methods, grounding, overcurrent protection, and the use of personal protective equipment, or PPE. Electrical safety training is essential for workers who work with or near electrical equipment and systems. Electrical codes are sets of rules and regulations that govern the safe installation and maintenance of electrical systems. Electrical codes are developed by organizations such as the National Fire Protection Association, or NFPA, and are adopted by state and local government. Compliance with electrical codes is essential for ensuring the safety and reliability of electrical systems. Electrical standards are sets of guidelines and specifications that define the requirements for electrical equipment and systems. The electrical standards are developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. Compliance with electrical standards is essential for ensuring the performance, safety, and interoperability of electrical equipment and systems. Electrical hazards are dangers associated with electricity, such as electrical shock, electrocution, arc flash, and fire. Electrical hazards can be caused by faulty equipment, improper wiring, or unsafe work practices. Awareness of electrical hazards and adherence to safety procedures are essential for preventing electrical accidents. Lockout/tagout, or LOTR, is a safety procedure used to prevent the accidental energization of equipment during maintenance or repair. LOTR involves isolating the equipment from its energy sources and placing locks and tags on the energy isolating devices to prevent them from being turned on. LOTR is essential for protecting workers from electrical hazards and other types of accidents. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or arc fault in electrical equipment. Arc flash can cause severe burns, blindness, and even death. Arc flash protection involves using arc-resistant equipment, personal protective equipment, and safety procedures to minimize the risk of arc flash hazards. Electrical shock occurs when a person comes into contact with a live electrical conductor and current flows through their body. Electrical shock can cause burns, muscle contractions, heart fibrillation, and death. Electrical safety procedures and equipment, such as ground fault circuit interrupters, are used to prevent electrical shock hazards. Electrocution is death caused by electrical shock. Electrocution can occur when a person comes into contact with a high voltage electrical conductor and a large amount of current flows through their body. Electrical safety procedures and equipment are used to prevent electrocution hazards. Static electricity is an electrical charge that builds up on the surface of a material. Static electricity can be generated by friction, contact, or separation. Static electricity can cause sparks, shocks, and damage to sensitive electronic equipment. Static electricity control measures, such as grounding, bonding, and the use of antistatic materials, are used to prevent static electricity hazards. Capacitance is the ability of a component to store electrical energy in an electric field. Capacitors are used to store energy, filter signals, and provide timing functions in electrical circuits. Inductance is the property of a circuit that opposes changes in current. Inductors are used to store energy, filter signals, and provide impedance in electrical circuits. Reactance is the opposition to the flow of alternating current, or AC, due to capacitance or inductance. Reactance is measured in ohms and is frequency dependent. Impedance is the total opposition to the flow of alternating current, or AC, and includes both resistance and reactance. Impedance is measured in ohms and is frequency dependent. Admittance is the reciprocal of impedance and is a measure of how easily alternating current, or AC, flows through a circuit. Admittance is measured in Siemens. Susceptance is the reciprocal of reactance and is a measure of how easily alternating current, or AC, flows through a capacitor or inductor. Susceptance is measured in Siemens. Inductance is the reciprocal of resistance and is a measure of how easily direct current, or DC, flows through a resistor. Conductance is measured in Siemens. Power is the rate at which electrical energy is transferred or used. Power is measured in watts. Voltage is the electrical potential difference between 2 points in a circuit. Voltage is measured in volts. Current is the flow of electrical charge through a circuit. Current is measured in amps. Resistance is the opposition to the flow of electrical current. Resistance is measured in ohms. The frequency of an alternating current, or AC, signal is the number of cycles per second. Frequency is measured in hertz. The period of an alternating current, or AC, signal is the time it takes for one complete cycle. The period is the reciprocal of the frequency. The wavelength of an electromagnetic wave is the distance between two successive crests or troughs of the wave. Wavelength is related to frequency and the speed of light. The amplitude of a signal is the maximum value of the signal. The phase of a signal is the position of the signal in time relative to a reference point. The duty cycle of a pulse signal is the percentage of time that the signal is high. Harmonics are multiples of the fundamental frequency of a signal. Total harmonic distortion, or THD, is a measure of the amount of harmonic distortion in a signal. Signal-to-noise ratio, or SNR, is a measure of the strength of a signal relative to the background noise. Crosstalk is the unwanted transfer of a signal from one circuit to another. Interference is any unwanted signal that interferes with a desired signal. Shielding is the process of using a conductive barrier to block electromagnetic interference. Grounding is the process of connecting a circuit to the earth to provide a reference point and prevent electrical shock hazards. Bonding is the process of connecting metallic objects together to create a low impedance path for fault currents. Filters are circuits that selectively pass or block certain frequencies. Amplifiers are circuits that increase the amplitude of a signal. Oscillators are circuits that generate periodic signals. Converters are circuits that convert one type of electrical signal to another. Power supplies are circuits that provide electrical power to other circuits. Control systems are circuits that control the operation of other circuits or devices. Communication systems are circuits that transmit and receive information. Sensing systems are circuits that detect and measure physical quantities. Actuation systems are circuits that control mechanical devices.